While we continue to look at linear equations in two variables, we're going to be spending a lot of time looking at different notations and forms of linear equations. One of them is what we call standard form, where we have both variables listed on one side of the equation set equal to some constant. Typically, our linear equations in one variable, we like to have the terms be integer coefficients and constants, but sometimes it's a little more just semantics, and we can also have decimal values or even fraction values. Depending on the situation, we may leave them there, or we may convert them into integer values by doing some equation manipulation. We can model many real-life scenarios with linear equations. Suppose you work for a store that sells office products. Your pay is going to be a $3,000 salary plus 20% of the commission. If we let X represent the value of the product sold and Y represent your monthly salary, how much money you would make, we can model your salary using a linear equation where you always receive the $3,000 base pay plus your 20% commission. And when we add those together, we get your total income for that month. So here we have listed some ordered pairs where X is our products and then the monthly salary that would equate to that. If you sell 0 products, you earn $3,000. $1,000 worth of products, you earn $3,200, and so on. Now again, these are not the only ordered pairs, but these are several that we can plot, and we see this linear relationship that goes through. Any point that we could plot on this line is considered a solution to the equation, even these points here in the middle. So there's an infinite number of combinations of how much money you could earn based on how much product you sell. We can use graphs and we can use linear equations to analyze different aspects of the situation. So here, if a salesperson sells $8,000 of product in a particular month, what is the salary for that month? And so what we can do is look at our graph and identify $8,000 in product sold and see the corresponding ordered pair that is created by that line. And we see that 8,000 corresponds with $4,600. Therefore, when you sell $8,000 in product, you earn a revenue of $4,600 for that month. If we wanted to, we could also find that solution from our equation just by substituting the value of X into the equation rather than looking on the graph. We could plug in the $8,000, and when we evaluate it, we get a value of Y that equals $4,600. Next, we could look at how much, if the salesperson wants to make more than $5,000, what must be the total amount of products sold? Since this is talking about how much money they earn, we want to look on the Y-axis and find the corresponding point, and that indicates that $10,000 worth of product would need to be sold in order to earn the $5,000 per month. And again, just like with before, if we wanted to use the equation, instead we could substitute 5,000 in for Y, and then solve the equation for X, and then we would get that $10,000 equals X. So continuing looking at our graph, if the salesperson wants to sell $6,000 of product, how much would they earn? So 6,000 on the product sold equates to $4,200 in revenue earned. So they would earn $4,200. And then last but not least, if they wanted to make $4,800, that's going to be this point right here. 4,800 corresponds to an X value of 9,000, so they would need to sell $9,000